We're going to look at the subject of color-proof settings. Now I have a number of images here and I'll quickly explain what they are and why I have them here. First of all, on the left I have the 3 RGB colors. Then I have the 4 CMYK colors, and this image here represents in the brighter section a mixture of RGB colors, and the inner section is a mixture of the CMYK colors. I'll say this another way. The brighter section are what we call out of gamut colors for printing. However, the CMYK area here are in gamut colors for printing. Now, this bitmap is an RGB based bitmap made up of these 3 colors, and both this vector and bitmap image here are CMYK images made up of these 4 colors. In fact, this bitmap image here is the exact same one. I simply converted to CMYK colors. Let's just simply go with the standard settings we have here in the color-proof Docker, and let's watch what happens. And the first thing that you will notice is all of the RGB based colors or images within this document have become flat, and in fact they now match the range of CMYK colors. Notice how the RGB colors out here now match my CMYK range of printable colors. Even the RGB bitmap now matches the CMYK version of the same. And the reason for this is based on the settings here in the color-proof Docker. All non-printable colors have been shifted into a range of printable colors, this range of colors in here. Now this shift takes place based on 2 settings. First of all, what is the color profile we're trying to simulate? And secondly, what's the method of shifting those colors? We call that the rendering intent. Let's have a look at how the rendering intent works. The first option we're going to look at is relative colorimetric, which is the default. Now watch this. I'm simply going to turn on proof of colors, but I'm also going to turn on out of gamut colors. Now everything that's highlighted in green here, as you can see, is really non-printable. But what we're wanting to do here is, of course, shift everything into a printable range of colors. And this is what color proofing does, and this is what the rendering intent does. These colors that are in this unprintable out of gamut range, well, they have to be shifted into the CMYK range of printable colors. Let me turn this off. These 2 points here of yellow will both be shifted to the brightest available printable color in the CMYK range of colors. This blue here will again be shifted to the brightest available blue within the range. Now I've depicted this here based on this image. This blue very much matches this blue. When I turn on proof colors, this blue will convert very close to this color or range of colors. So as I turn that on, you can see that color there very much matches that color there. And really, this is what the rendering intent does. It makes a decision on how to shift the colors into the range of printable colors. The other thing that relative colorimetric does is it takes into consideration, based on the profile, the color of the substrate or the paper we're going to print on. So what we're looking at has a white point that has been shifted so that we accurately see what the end print will look like. If I now go ahead and change this to absolute colorimetric, the first thing you'll see is that the background color changes. Now the reason for this is absolute colorimetric looks into the profile and says, okay, well, this is a depiction of the color of the substrate represented in this profile. Therefore, this is what this image would look like. It shows us this without changing the white point or the CMYK values. It maintains the integrity of those values. It uses the same method to shift the out of gamut colors into the CMYK range of printing, so that method is the same, but the white point is not adjusted as it is with relative colorimetric, and that's the primary difference. Looking now at the perceptual option. Unlike the relative colorimetric we learnt about earlier that takes these 2 points of yellow that are out of gamut and shifts them to one single point, the brightest available point that can be printed, the perceptual option tries to maintain the relationship between all colors. So that brightest yellow, well, that's moved to the brightest available point, but that next yellow along, as you can see, it's mapped further into the CMYK range. You'll even notice the green has also been remapped to a different point as well. What perceptual does is it takes all points within your image whether they are out of gamut or in gamut, and it shifts them all together, maintaining the relationship between all of the colors. Now, the advantage of this is that all of the critical tonal and detail information about your image is maintained. However, it's not quite as color accurate because even the colors that were in gamut, they are also shifted. And our last option, saturation, and probably the least used option, this option moves color slightly differently. For the colors that are out of gamut, it moves them in the same way toward the brightest available printable point. However, colors that are in gamut, printable colors already existing within our range, they can be shifted out to a brighter point. Or, if you like, the result is a brighter, more color saturated image. Quite suitable for business graphics, but you would not want to use this option if you're working with photographic information. Now that we understand the process of remapping colors into the selected environment, the shifting of colors to match the chosen color profile, I'm going to choose a different profile. I'm going to choose Japan Color Newspaper because it has a very limited color range. I'll turn on proof colors, and the result is quite flat and dull, which is what you would expect because it's printing on newspaper. The RGB values have been mapped to a color range that fits this profile, as have the CMYK based images. But watch this. If I turn on preserve CMYK numbers, notice only the CMYK images change. What's really happening is I'm saying, okay, I don't like your mapping. I would rather keep the values that exist. What do they look like when printed in this environment? And in fact, I like this result better. I think they actually match the mapping of the RGB better. Preserving CMYK numbers can oftentimes be a good thing to do, so look at it when you're working with different environments. Well, of course, once we've made all of the decisions that we've been discussing for the last few minutes, we want to create a soft proof. We have a few options available. I'll quickly create a PDF file. The thing that I really want you to see here is under the Color tab. Because we have come from the Color Proof Settings Docker, by default, Use Color Proof Settings is turned on and the profile we've chosen is automatically embedded. We could choose the document color setting if we wanted to, but of course we're proofing what we've already set up. So let's click OK and see what it looks like. As you can see here, Reader, of course, is using the profile information we have embedded, and hence we're seeing the same color result as we have in our original document. Well, one last thing, I quickly want to export a soft proof as a JPEG. And the thing I want you to see here is, again, by default, because we've come from the Color Proof Docker, Embed Color Profile has been selected. And that's why we're seeing an absolute result here. So when I click OK, it will use this color profile, tag this image, and my end user will see it the same way I am seeing it. The last area we will look at is print proof. And this brings up the print dialog box. Now, first off, I want you to notice there's a new tab called the Color tab. The tab alongside is called Composite, and that's because I have Composite selected. If I choose Print Separations, it changes to a Separations tab where we can go and make some adjustments. I want you to see that the colors are being output to my printer in RGB. The reason is because the printer I have is a Windows-based printer, or GDI printer. It must receive the information as RGB. Therefore, all of the CMYK colors in this document have to be converted, and that conversion will take place based on the selected profile. Now, your Windows printer, if you have one, may have a different profile to this that was installed with your printer. After printing, if you're not happy with the results, I recommend that you choose this particular profile. It's the same profile we chose when we created our document as to how images would be rendered to the screen. Give it a try. If you work with a PostScript device, I'll select one here, you have some additional options. You can output as CMYK or RGB, and of course everything works as discussed. Or if you turn on Use Document Color Settings, you can choose whether Corel Draw performs the color conversion, or if you choose the PostScript device, it will do all of the color converting for you.